This episode is sponsored by Photozyme. Photozyme DNA repair enzymes are important because they help to protect the skin from photodamage and promote healthy cell growth. When the skin is damaged by the sun, it can become dry, wrinkled, and discolored. DNA repair enzymes can help to repair this damage and restore the skin to its natural health and radiance. As published in the Journal of Drugs and Dermatology, Photozyme DNA repair enzymes are foundational and an absolute must for healthy aging skin. Hi, I'm Dr. Patty Ferris. I'm a board-certified dermatologist, and I am your host for this episode of Skincare Confidential. Just a reminder, Skincare Confidential is an outreach of our medical meeting, the Science of Skincare Summit, which we're very excited is going to be held in Austin, Texas this year, November the 8th through the 10th. It's a medical meeting designed to teach healthcare professionals about the science behind topical skincare products and how to best utilize them in their practice. And today we have one of the incredible brains and experts. I've read so many things you've written over the years, Dan. I'm so excited about this interview. I really have. I followed a lot of the science that you've put forward. And if you don't know Dan Yarosh, I'm going to tell you, if you say DNA repair enzymes to a dermatologist, they're going to say Daniel Yarosh. And I'm going to give a little bit of your bio. Your bio's, so lengthy, I can't read it all, but you have a bachelor's degree in biology and a doctorate in molecular biology, which you got at the University of Arizona. You also served as a National Science Foundation Fellow at Brookhaven National Laboratory, and then as a staff fellow and cancer expert at National Cancer Institute at the NIH. So impressive. You founded a biotech company, and I remember this company, Dan, AGI Dermatics, because I knew some people who worked there years ago. And the emphasis of this company was on the application of DNA repair enzymes. You're the inventor of Dimericine O, which is a liposomal lotion containing T4N5, which we're going to talk about if you don't know what it is. And then in 2006, the company launched its own brand, Remergent, which I also remember, which was sunscreens and prescription drugs. And then in 2008, that company was acquired by Estee Lauder. And congratulations on that. And then Dan is also the author of 140 scientific papers. He has more than 24 patents. So accomplished. And you also received the very esteemed Finstein Award, which is presented every 4 years at the International Congress of Photobiology for breakthrough research. So congratulations. What a career. And like I said, I have followed your work. I've presented it on podium, and I'm very excited about this interview. So thanks for taking the time.
Oh, Patty, thank you very much for having me. It's a pleasure. I've listened to some of your podcasts, and I'm very impressed. So I'm very delighted to be here with you today.
Thank you. So it's kind of funny, Dan, because both of us pulled the same paper. When I was going to do this interview, I'm like, I haven't talked on DNA repair in a long time. I better pull something. And I remembered that you had written with Ron Moy and somebody else. I'm sorry, I don't remember the other author.
Amanda Rosenthal.
That's right. Amanda Rosenthal. An article like the 6 burning questions is what I would call it, that doctors have about DNA repair enzymes. And I think there's a lot of confusion about this. I think there's a lot of questions about this. Do they really work? What are the benefits? So I'm going to actually use the article as a template for the interview because it was so well written. And who better to answer these questions than you? So we're going to start with something super simple because we're going to set the stage here. And that is, talk first about the types of DNA repair enzymes so people understand that there are various types of DNA repair enzymes.
Yeah, so the body needs to be able to repair its DNA. Without it, there's a disease well known called xeroderma pigmentosum, and these people get skin cancer before the age of 8. Their life expectancy is shortened because they don't have an intact system to repair DNA damage. DNA damage caused by all things, but the number one thing that gets them is sunlight. So the biggest challenge our DNA has is sun exposure, because it just turns out the wavelengths, the short wavelengths of UV are exactly the wavelengths that DNA absorbs. And when it absorbs those UV light rays, it undergoes a chemical transformation, and this ruins the DNA. It's as if you're reading a book and you get to the last chapter and somebody tore out the pages. So when the UV damages a DNA, the instruction manual is gone, and that's when you have consequences. There are things other than UV that cause DNA damage, and some of that is oxidative damage. So people talk about free radicals and oxidation. DNA can be oxidized, and there's enzymes that repair oxidation. There's also another form of chemical damage called alkylation, where an alkyl group, a carbon-based group, gets attached to the DNA. This also destroys a coding capacity, and there are DNA repair enzymes that are built just to remove this alkylation damage.
So that's so interesting. Alkylation I was not familiar with. So talk about some of the different types of enzymes, the endonucleases, the
Yeah.
photolyases, and
So there's two large categories. One are the ones that go in and snip out the damage to the DNA. They're amazing enzymes. They bind to DNA and they travel along the strand looking for a distortion. And this distortion is the damage. And they have a pocket in the enzyme that fits that damage. So they don't really stay very long on the DNA that's normal, but as soon as they find the damaged DNA, that distortion fits into the pocket of the enzyme, and the enzyme makes a break in the DNA at that site. And that triggers a whole series of events because the body does not like to have DNA with breaks in it. So when it learns about the break, it sends in a whole team of enzymes which snip out a section of the DNA around where the first snip was made, and then using the other strand as a template, synthesizes fresh, clean DNA. So that's the first big category, and that's the category that's damaged in the case of this disease, xeroderma pigmentosum. They're missing one of these enzymes, and they just can't do the snip and repair. The second kind is a kind of repair that's only found in plants and reptiles, and it's called photolyase. And this is an amazing enzyme. It, again, finds the distortion in the DNA and binds to it, and then it looks around for a ray of light. And it is actually able to absorb light and do chemistry to split the damage. So rather than have to snip it out, it does the chemical reverse of what caused the damage in the first place. This is all mediated by an enzyme called photolyase. And then when the repair is done, the enzyme lets go and floats away and goes looking for more damage. So when we realized that this photolyase was out and about, then the obvious thing is, well, it's too bad people don't have it, but can we add it back to human cells and will it work? And at the time we were doing this research in the early 80s, there was a bet in our laboratory whether it would work or not. And half the scientists said, never work. You can't get a plant enzyme to work inside a human cell. And it turns out they were wrong. DNA is DNA. And if you can fix it, the cell is very happy. So these plant enzymes do, in fact, work in human cells.
so fascinating. So you began incorporating them into topical skincare products. So talk about that.
Well, the idea is that DNA repair is good, but it's not perfect. And the biggest thing is that it takes time. And while the DNA is sitting there waiting to be repaired, the cell needs to use its DNA, its instructions. And so the longer that damage is there, even if it's eventually repaired, the more trouble the cell is in, and the chance for there being a mutation, a change in the DNA base if it's not repaired. So the idea was, let's speed up the process of repair by putting in more of these nicks in the DNA, the breaks at the site of the damage. And it turns out that is the rate limiting step. So the thing that slows down DNA repair is the search and destroy mission of the first enzyme. So by adding more first enzymes, the other enzymes are there primed and ready to go. So we didn't have enough within the human cell, but we cloned genes for enzymes from bacteria and bacterial viruses that make a very small, very efficient protein. And we added it back, and that sped up the whole process. So by speeding up the first step, you can speed up the whole process.
That's phenomenal. So when these were liposomally encapsulated then and incorporated into sunscreens and various skincare products, they were tested on xeroderma pigmentosa patients, I remember initially.
Yes, that was a perfect model for this. And yes, I should have mentioned it's not enough to have the enzyme, because if you just rub enzymes on the surface of the skin, nothing happens. Your skin's not so easy to get through. So we developed a method for encapsulating them inside these microscopic lipid vesicles, the little balloons. They're made out of lipids, and we put the enzymes on the inside. And then when we put that on the skin, those liposomes are able to find their way into living cells and be taken up. So that was the delivery vehicle. And yes, the first big testing was done in the case of xeroderma pigmentosum, where we could show first that if you put these enzymes on the surface of their skin, it increased repair. And then over a longer time, these people get skin cancer at very sad, very high rates. And so we were able to reduce the rate by over 2/3 over the course of a year by using the DNA repair enzymes.
Yeah, that's fantastic. What an intervention from such an at-risk population. This episode is sponsored by Photozyme. Photozyme DNA repair enzymes are important because they help to protect the skin from photodamage and promote healthy cell growth. When the skin is damaged by the sun, it can become dry, wrinkled, and discolored. DNA repair enzymes can help to repair this damage and restore the skin to its natural health and radiance. As published in the Journal of Drugs and Dermatology, Photozyme DNA repair enzymes are foundational and an absolute must for healthy aging skin. Talk about some of the studies with regards to actinic keratoses and prevention of skin cancer in healthy subjects.
Yes, healthy subjects. And this goes back to a problem. And sometimes there's medical problems, and sometimes there's government payment for medical care problems. And in the early days when we were first involved, the medical opinion was actinic keratosis is a separate disease. It doesn't necessarily have anything to do with skin cancer. There are skin cancers, there's actinic keratoses, they're two different things. Primarily because the government didn't want to pay skin cancer rates to medical professionals to treat precancers, the actinic keratoses. So what we showed was that when you increase DNA repair, not only do you prevent cancers, but you prevent actinic keratoses. That these are cells that are halfway down the road to cancer because they did absorb UV, they do have DNA damage, they do have mutated cancer genes. They just haven't gotten all the way to skin cancer. And so what was amazing was not only did we prevent formation of actinic keratoses, because in the xeroderma pigmentosum trial, the patients were scrubbed clean before they started. But then there were additional studies that were done with people who already had actinic keratoses. And when you add DNA repair to these people's skin, the actinic keratoses regress. They go away. And that's probably because the immune system is suppressed when you have a lot of sun damage. And that allows the outgrowth of these actinic keratoses. So by repairing the DNA damage, we gave the immune system a chance to come back. And then this restored immune system looks around and it sees these actinic keratoses and he says, I know what to do with these. Let's get rid of them. So it brings me to a point, if I can just diverge for a second. Sometimes there's a common attitude, well, I had a lot of sun when I was a kid. There's not much I can do about it now. I'm just going to have to live with my fate. And that's absolutely not true. There is damage that's done in your youth that carries over into adulthood, but it's your ongoing UV exposure that also contributes to your risk. And that's because the damage you got yesterday is suppressing your immune system. And when you suppress the immune system, you allow these cancers to grow out. So people shouldn't give up. They shouldn't say, oh, my fate is sealed. I sunbathed when I was a kid. No, it's sun protection now can have a lot of benefit.
That's so interesting. Talk a little bit, because we haven't really mentioned OGG, and you mentioned oxidation, and we know that you can get oxidation of guanine, and that can ultimately contribute to DNA damage. But talk about that DNA repair enzyme.
Yeah, so this is an enzyme in a lot of ways that are similar to the UV enzymes, except they just recognize a different kind of damage. And one of the most common forms of oxidation damage to DNA is when the guanine base, the G and the AGCT, it gets oxidized at the 8 position. And this distorts the DNA strand because now the guanine can't pair like a normal one. And in fact, it wants to pair with the wrong base. And so these, even though it's a very small change in the DNA, it has huge consequences because the guanine doesn't pair with the cytosine that it's supposed to. It likes to pair with the thymine. And if that gets replicated, then you get a switch in the DNA reading. Instead of a GC, you get an AT. And that's like, again, like changing a key word in a chapter. If you're about to reveal the victim or you're about to reveal the perpetrator of the crime, and then you change the name, it ruins the whole book. And so that's what happens when you have this kind of oxidation damage. There are enzymes in normal skin to repair it, but again, it's a race. It's a race between the enzymes to get there and remove this damage and the cell to use that piece of DNA that's got the bad information. So even though eventually the oxidative damage would be repaired, the faster, the better.
So interesting. So now you made a good point. A lot of people feel like the damage that they had a long time ago, they're sort of stuck with. Are these helping with that old damage as well?
Well, probably not. The if a normal person will remove half their damage in 24 hours, and another 24 hours are down to a quarter, and another 24 hours. So, if you try to look for DNA damage in people's skin, it's very hard to do. You need extremely sensitive methods because it's present in such a low level. So these enzymes aren't for the damage you got when you were 15 or 20 years ago. It's for the damage you got over the last week. But again, that damage from 15 years ago has to grow out in order to be a problem. And you have a healthy immune system. So that's your secondary defense is keeping your immune system ready to get rid of these cancers. And you see this in other areas of cancer research. The focus is getting the immune system to work. It's not so much trying to kill the cancer cell. That's a good thing to do. But getting your immune system to eliminate cancer cells is the best strategy. And the same thing is true with skin. Keep your skin and your skin immune system healthy, and it'll do as much work as you want trying to get rid of the damage from when you were 15 years old.
So have there been studies, and I think there have been, looking at sunscreens with DNA repair enzymes as opposed to sunscreens alone?
Yes, there have been, and in several of these cases, of course, the sunscreens prevent DNA damage because they block the rays from even reaching the skin. But when you add DNA repair enzymes to it, they're even more efficient. And part of that is that people don't always apply the sunscreens in the right way or in the right amount. They think they're getting a SPF 15, but they only put on enough to get a 7 or a 5. They don't rub it on evenly. And so the enzymes provide a secondary a barrier. They go on and search out this DNA damage that maybe the sunscreens weren't perfect in blocking in the first place. So there's several studies that have shown that adding enzymes to sunscreens have a lot of benefit. And of course, some of the sunscreens are unstable. So even over time, they will decay. Whereas once the enzymes get into your skin, they'll last for a day or two.
Can these enzymes be added to both the mineral sunscreens and the chemical sunscreens? Are they compatible with both?
Yes, both of those types of sunscreens, the types that work have to have a water phase. So there has to be some place for the liposomes to exist in the formula, which is in the water. But most of these are emulsions that have both an oil phase that solubilize the sunscreens, the sun filters, the organic or the inorganic, but also allow a place for the enzymes to live. So yeah, studies have been done and shown both the chemical and the mineral sunscreens can be helped by adding DNA repair enzymes.
And so, we're talking so much more now about sunscreen safety, as you know, particularly after all the Food and Drug Administration studies that came out a couple of years ago showing systemic absorption. What about safety of DNA repair enzymes? I'm sure that's been looked at.
Yeah, so of course there's a concern. Anytime you add an enzyme that's going to do something to DNA, you have a concern. So the beauty of enzymes is that they are absolutely specific. They have a 1 billion times preference for their substrate, which is the damaged DNA, over undamaged DNA. And in fact, that's the way all enzymes have to work. You have them everywhere. They don't do everything all at once. They wait for their spot, and that's because they bind specifically to a target. So the great safety feature of DNA repair enzymes is they leave the DNA alone until, as I said, there's a damage distortion that fits into the pocket like a lock and key. If there's no key, then the lock doesn't work. And so there have also been studies looking to see, do we raise antibodies against, do we get allergic reactions? These are very small enzymes, so we have never noticed or had a report of an allergic reaction from the enzyme itself. So these have been looked at in lots of safety studies, and so far, no serious concerns.
And they don't lose their effectiveness over time.
Well,
No.
once they're applied to the skin, they have a lifetime because they get in and the skin is always turning over enzymes. But there are ways that they're, good formulas are stable for 3 years, though the emergent ones we tested for more than 3 years. And now I'm going to add an editorial comment. So I'm not a big, I know people make products that have sunscreens and DNA repair enzymes in them. I'm not a big fan of that combination, although it's better than nothing. But the purpose of sunscreens are to sit on top of your skin and to deliver their filters on the surface. You don't want them going into skin for safety reasons and also for efficacy. Their job is to be on the surface and to catch the rays. The DNA repair enzymes, that's not where they're supposed to go. They're supposed to penetrate into the living tissue. And so my preference would be you put on your DNA repair enzymes and then you put the sunscreen on top. Or you use the sunscreen during the day, and then at the end of the day, when you've accumulated whatever damage has slipped past the sunscreens, then you add your DNA repair enzyme. So when people ask me what to do, that's what I recommend. But of course, if you have a sunscreen with a DNA repair enzyme, go ahead and put it on.
Yeah, better than nothing, as you said. That was a question I was going to ask you, whether you had a preference to the combination products or the DNA repair alone. And what about compatibility? So I like your idea of you using your sunscreen during the day and you using your DNA repair enzymes at night. Compatibility with things like retinoids, which of course we're all using at night, topical vitamin C's. Is there any compatibility problems with really any of these topicals that are pretty popular right now?
Well, I think the way to think about it is the things that you want to work deep in the skin, you put on first. And so things like DNA repair enzymes, nutritional items, vitamin C's, and things like that, you want to put those on first, give them the best chance to penetrate. Things like retinoids do their work closer to the surface of the skin. They encourage cells to de-differentiate, not to become so mature so fast. That plumps the skin. It gives a nice color and texture to it. People love the retin-A effects on lines and wrinkles.
Mm-hmm.
It does tend to thin the skin because you have fewer cells acting like mature cells that are making the surface proteins and the thin stratum corneum, and more cells acting like they're at the bottom of the skin. That gives that plump look. So I would put on the retinol products after you've done the nourishing and the DNA repair, the lower levels. And then, of course, when you thin the skin with retinoids, you should have sunscreens to protect.
Absolutely.
But if you think about
Sunscreens.
where things are working in the skin, put those deep things in first.
So let's talk about photoage skin. Not as I always call actinic keratosis and skin cancer the terminal form of photoaging. Let's talk
Yes.
about other types of photoaging, hyperpigmentation, lentigines, wrinkles. Have DNA repair enzymes been shown to have any benefits there?
Yeah, so those are actually very good points. So let's talk about hyperpigmentation. So there's the pigmentation is a response to sun damage, and it's the way the skin and particularly the melanocytes respond to the damage, saying, "Uh-oh, I don't know what to do. The thing I do know how to do is make pigment. I'll make pigment, and that pigment will help protect the cells around me because the melanocytes transfer it to the local living cells." So when you increase DNA repair, you take away some of the signals for pigmentation and you get a more even skin tone. You don't get those spots, the hyperpigmentation spots. And there have been several studies that show that. And it makes sense from a why do we have pigment point of view. But there are several
Mm-hmm.
kinds of pigmentation that it doesn't have effect on, and those are the moles. Those fall into a whole different category of pigmentation. They're not necessarily related to sun exposure. They can give rise to melanoma, some of them. And so just because you're using a DNA repair enzyme doesn't mean you should ignore your moles or that you're not having an effect. That's a different kind of beast, and you need to keep a close eye on them. But the type of hyperpigmentation and an uneven skin tone that most people are concerned about, yes, they respond to DNA damage. And then
And I
the
think
other thing,
wrinkles too.
and well, so wrinkles are lots of theories about it, lots of discussion about it. Primarily, it's a problem of collagen, that you have this very tight network of cables made out of collagen. And one of the things that happens when you have sun exposure is you trigger what we call a wound healing response. Your skin acts as if it's been wounded, not just the DNA, but the tissue itself has been wounded. And one of the things the skin does is release enzymes called MMPs, metalloproteases, which they're used in wound healing to debride, to get rid of the debris of the field, clean it up so the skin can be healed. But when you release MMPs, the thing they do is chew on collagen. And so usually sun exposure isn't so severe. You have these repetitive rounds of damage, repair, damage, repair, damage, repair. You release a little bit of MMP, then you stop, then a little bit more. It's this accumulation of damage and repair that leads to wrinkles, because the little bit of damage to collagen this time, the next time there's a little bit more. And frankly, the MMPs, if they start chewing on collagen, that's the first place they go back to chew on again. So it's very hard for the skin to keep up. And there is some ways of stimulating collagen production. Vitamin C is one of the best ones. But when you use DNA repair enzymes, you take away the signal for the MMPs. And so plenty of studies, both in cell culture and in skin, show that when you increase DNA repair, less of these collagen chewing enzymes appear. And there have been clinical studies showing improvement in lines and wrinkles over a matter of months when you use DNA repair enzymes. So these are all trying to calm down the wound healing response, to get rid of the damage as fast as possible.
So that's a win-win. Less skin cancer, less actinic keratosis, and less wrinkles. I think everybody's going to run out and buy some DNA repair enzymes
I
after
hope they appreciate
after listening.
I hope they appreciate there's tools available.
Absolutely. We're sort of getting close to the end, but I want to ask you, because you've created companies, you've sold companies. What are you doing now in the business world, and what do you really see as the future? I mean, you were on the cutting edge of the future. Um, and what do you see now coming down the road that you find exciting and interesting? I mean, everyone is talking about exosomes and all this regenerative medicine stuff. So I'd love to hear your thoughts on all of
Well,
that.
I'll tell you what, that could be a whole nother session
Well,
about
that is a
all
podcast.
the
Yeah,
different.
we've done a
But I'll
podcast
tell
or
you
two on it.
what I'm involved in that I find so exciting. So when I first started, cloning was a huge deal. You know, could you take a gene, cut it out, put it into the right place, grow it, and then it'll produce an enzyme you never had before? Oh man, that's fantastic. So then the next technology was, well, can we take it from one organism and put it into another organism and get it to work? Get a bacterial gene into a yeast and get it to work. Oh man, that's fantastic. Well, that went on for a long time. Then people said, well, let's take an enzyme and let's grow it up, and then let's break the cell open and get the enzyme out. And that was the basis of the liposomes. And now they're making enzymes that are now the machines. So if you can picture this, you start out with a starting chemical and you pass it over a column that are loaded with these enzymes, and they do all the work. They do all the chemistry. And out of the bottom of the column comes a transformed molecule. So, for example, one of the things that I'm involved in are nutritional items. So there's some things that we still rely on cows to make in terms of milk and baby formula. But imagine if you could get the enzymes that go into that and produce it outside of the cow. Now you can make baby formula that has all the nutrition of milk, but you haven't used any cow milk at all. And you can get rid of the allergens. You can just have the nutrients that you want. So this is called synthetic biology, and it's using enzymes as tools rather than relying on them being in a cell or being cloned. It's cell-free synthetic biology, and it's going to revolutionize chemistry. The chemists are all afraid, and I'm trying to help some companies that have been dependent on chemistry try to embrace this new technology, because all those test tubes and boiling pots and steam coming out are going to be a thing of the past. Enzymes are going to do the work that used to be done in kettles and boiling pots. So that's one aspect that I'm very excited about now, and I'm working with companies on.
That's totally fascinating. Are you still in the skincare industry as well?
Yes, yes. So I'm advising companies on how to transfer their technology. That's really where my expertise sits, is understanding the technology and understanding the business side and trying to find a way to make the technology commercially viable.
Right. Fantastic. Well, listen, I can't thank you enough for
Yeah.
spending part of your day with us at Skincare Confidential. This was so informative, and I know everybody out there is going to really enjoy this episode. And what a pleasure to meet you.
Thank you, Patty. I really enjoyed it too. We talked about my favorite subject, and I always enjoy sharing, and I appreciate the opportunity to be on your podcast, which so many people watch and respect. It's great.
Thank you so much. We're putting you on the list for our meeting as well. We had Ron Moy speak last year, so I think you'd approve of that, because I know y'all work together. You did a great job.
Thank you.
Now that we've got your email, you're on our list. Thanks so much. Have a great day. Bye-bye, Dan.
Bye-bye.
This episode is sponsored by Photozyme. Photozyme DNA repair enzymes are important because they help to protect the skin from photodamage and promote healthy cell growth. When the skin is damaged by the sun, it can become dry, wrinkled, and discolored. DNA repair enzymes can help to repair this damage and restore the skin to its natural health and radiance. As published in the Journal of Drugs and Dermatology, Photozyme DNA repair enzymes are foundational and an absolute must for healthy aging skin.